I wanted to do a little review of computing history. I've given you 2 other lectures, and I'm going to include some new devices on this one. But I just wanted to do a quick review so that you understand that when we talk about computing history, we tend to break the devices into different categories, and I wanted you to see that a little more clearly here. When we're talking about the complete history, it's a little more obvious. So we've talked about the Pascaline and the stepped reckoner from the 16 and 1700s. Those were considered mechanical devices. They did not use electricity. They were cumbersome in the fact that each part, each gear was handmade, which led to them not being reliable because one might have been made perfectly and the next one that was made by some craftsman might have been slightly different. So you might have had one that worked, one that didn't work, one that worked inconsistently. But again, you have the idea of gears and mechanical devices with moving parts. And then we moved into 2 of the most important people in the 1800s, Babbage and Byron, who had the idea of the difference engine and the analytical engine, which were devices that were never built. They were just drawn out and they talked about them. And they proposed a stored program computer. The idea that you could put the instructions together, run the instructions over and over, that the computer could make decisions. And Ada Byron came up with the first program for these devices and is considered to be the first computer programmer. And of course we have a language, Ada, that is named after her. So again, those are considered mechanical devices. They had lots of moving parts and gears and things like that. And then we moved into the end of the 19th century, where the Census Bureau realized that they could not continue to calculate the census in a timely manner just with people alone. It was taking 10 years to calculate the census numbers. And so when the census of 1880 took about 10 years to complete, it was time for the next census, and they realized that that could not continue. So they put out a contest to see if someone could come up with something to help them count and compute the numbers a little more quickly, and Herman Hollerith did so. He came up with what's called the tabulating machine. It was an electromechanical device. So it used electricity rather than mechanical gears, and it used punched cards, which is something that would be used for many decades to come after Hollerith came up with that idea. So this machine was very successful. Hollerith started something called the Tabulating Machine Company, and that eventually evolved into what we know today as IBM, the International Business Machines Company. And from there, we had the Mark I, which came out in 1944, and was actually completed by a team from IBM and Harvard. Under the leadership of Howard Aiken, A-I-K-E-N. And this used mechanical telephone relay switches to store information, and it also used punch cards for data storage. However, it could not make decisions, and so it's not technically considered a computer. It was more of a sophisticated calculator. It was huge. It was about 51 feet long. It weighed 5 tons, and it had over 750,000 parts, some of them, again, mechanical moving parts. And so, again, we have unreliability here. But it was a step in the right direction. And out of that came the idea for the first generation computers, and we have the ABC, the Atanasoff Berry computer, which is the first electronic computer built between 1939 and 1942 at Iowa State University by Atanasoff and Berry, who were math professors, and I think Berry was actually a graduate student. And this one actually was one of the first devices to use the binary system that is still used today in modern computers. It contained lots of vacuum tubes, It used a sheet of paper that it burned holes in to store data, much like a punch card, and it could do lots of calculations. So from there, in June of 1943, we have another first-generation computer, the ENIAC, the Electronic Numerical Integration and Calculator, which was actually a secret military project during World War II that they put together to help calculate the trajectory of artillery shells. So originally we had devices where they were trying to calculate shipping tables. Then we move into World War II and they needed to calculate accurately the trajectory of artillery shells because, again, people were doing that. They were making mistakes in the complex calculations, and the tables for these trajectories would be wrong. And of course, in a war, that's a matter of life and death. So the ENIAC was part of the solution to that. Unfortunately, it was not finished until 1946, after the war had ended. But the ENIAC was yet another step in the right direction for computers and for what we know today as the modern computer. And it could solve problems, for example, that would take mathematicians 3 or 4 days to solve. It could do in 20 seconds. So it gave people, mathematicians, and so on, the idea that they could keep working on devices, that they could come up with something that would eventually evolve into what we have today. The ENIAC weighed about 30 tons. It took up 1,500 square feet, which is about the size of a 3-bedroom house. It contained over 17,000 vacuum tubes, and that consumed an enormous amount of electricity, and it also generated an enormous amount of heat when the thing was running. So they had to have lots of fans in the room to keep the thing cool. And we consider the ABC and the ENIAC to be first-generation computers because they mark the beginning of the computer era. A computer is, by definition, an electronic machine that accepts data, processes it according to some set of instructions, and provides results as new data. And it can make simple decisions and comparisons, and that is all that the computers we have today do as well. So from that, we move into the idea of the stored program computer. So these things that came before this, sometimes one or two of them could make decisions, but they really could not store programs. They were on punch cards that had to be loaded in through like a hopper type device every time that the program needed to be run. The ABC and the ENIAC required constant wire pulling, replugging, and switch flipping as well to change their instructions along with punch cards. So we have this idea, everybody's going to the stored program concept, but how to make it work. So one of the pioneers who came up with this idea of a universal machine was Alan Turing, and you may have seen the movie that came out recently about World War II and Turing's contributions to the British effort to crack the Enigma machine. Turing was a brilliant man. He had lots of very forward-thinking ideas when it came to mechanical devices, computers, and things like that. So he came up with the idea of a universal machine, and his vision was that this computer, this universal machine, would perform different tasks by changing programs. So it might have a program to do calculations and another program to do something like word processing. So here you have someone in the 1930s and 40s envisioning the computing device that we have today. That's all our computers do. They run different programs and multitask and switch between them. And so his idea was that you would change software or programs rather than having to go pull wires and flip switches as he was having to do with the devices that were around during his time. And he came up with the idea of a stored program, and the definition of a program is a list of instructions written in a special language that the computer understands, which of course we're doing that today with Visual Basic and Java and all these other things. And so he comes up with this concept, and around the same time, John von Neumann in 1945 presented his idea of a stored program concept that used a CPU, or central processing unit. So von Neumann's idea was that these stored programs would store the instructions in a CPU, which would have different elements, some for mathematics, some for logic, but the CPU would control all the functions of the computer electronically, and again, you would not be pulling wires, flipping switches, or loading punch cards for instructions. So these guys were visionaries. They started the idea, they presented papers to their peers, and these ideas started getting in the heads of the various people that also were interested in developing some type of computing devices. Now, von Neumann worked together with two other folks, Mauchly and Eckert, and they actually designed and built the EDVAC, the Electronic Discrete Variable Automatic Computer, and then they also built the EDSAC, which was the Electronic Delay Storage Automatic Computer, and they built them to solve problems by entering instructions that were stored on a paper tape. And these were in machine language. These instructions were in binary with zeros and ones. So zeros and ones now, binary, that's like the switch for on and off. But instead of going to the computer and flipping switches physically on this 3-room size computer, you're able to do that with binary, and you're able to do it on a paper tape with the EDVAC and the EDSAC. And we call that machine language, the zeros and ones, the binary that even today ultimately run your computers are called that's still called machine language. Now, the third computer that used the stored program concept in addition to the EDVAC and the EDSAC was the UNIVAC, the Universal Automatic Computer. This was built by Mauchly and Eckert. So von Neumann, Mauchly, and Eckert were building these devices that use stored programs. And the Census Bureau bought one of the first UNIVACs back in 1951. So they used vacuum tubes. They were still large. They were still expensive. Only large corporations or the government could afford them, but they could do 1,000 calculations per second. And they were very useful for the intense number crunching, particularly that the federal government and large corporations were doing. Then we move into the idea of the second generation computer, that in 1947, Shockley, Bardeen, and Brattain of Bell Labs worked on. They invented the transistor, and they won the 1956 Nobel Prize in Physics for that. The transistor made computers smaller and less expensive and increased calculating speeds by up to 10,000 calculations per second. So they were Shockley, Bardeen, and Brattain came up with the idea of the transistor, which allowed IBM in the 60s to introduce the first medium-sized computer named the Model 650. We're still talking about a pretty expensive device, but it was smaller. It could handle more calculations. It could handle the requirements of the federal government and large organizations, and it was very popular among those groups, federal government, large corporations, for data and number crunching. Now, these second generation computers also used magnetic tape that replaced punch cards, and we had the tape reels, so again, things could be done a little faster than they were with punch cards. Now, with mag tape, too, computers can read data and write data much faster, quicker, more reliably than they could with punch cards. And so since these first generation computers had more abilities than their predecessors, we came up with the idea of advanced high-level programming languages, with Grace Hopper of the Navy inventing COBOL, the Common Business-Oriented Language. From there we moved to third generation with integrated circuits, and I'll have to do yet another lecture to wrap up with mainframes, microprocessors, and personal computers. But you can see where I'm going with this by the list. So we have the integrated circuit by Kilby and Royce. Working independently of each other, they came up with the same idea. Today we call that a computer chip. And I'll have one last short lecture